You guys can see at my back there's a PowerPoint slides. Let me know if you're not able to see anything or hear anything from my side.
Can hit.
Okay, good. All right. Now in the second session, we're going to learn new things. It's called Taylor and Maclaurin series. We already finished power series. We already finished power series. Now we go into Taylor and Maclaurin series. So this is part of your test 1 scope. Okay. We will extend something that you learned in power series, go into Taylor and Maclaurin. So these are the questions we ask. So what about e power x? What about sine and so on? So far, we haven't touched on e power x. So far, we haven't touched about sine, trigonometry, power series. These are the graph pattern. On the left is e power x graph. And if you plot sine wave, your sine wave will go up, go down, and then go up, and then go down. So you should revisit how to plot e power x graph and how to plot x graph, sine x graph. However, in our module, don't worry about plotting graph. I will allow you to use online tools to plot graph. So where to find all these online tools? Just go to your Google platform, your Google, and then you search graph plotter. Okay, graph plotter. Go to the first link or second link also can. You will arrive at one website that you are able to plot graph. Okay, so later I will show you also. Okay, I will show you in later class. But there is a platform that allow you to plot graph. In our class, don't worry if you don't know how to plot graph, but I will teach you how to use online tools and use that as your part of your answer. Okay, you just trace what you see on the website, put into your answer. Okay. Okay. So just now, before the break, we mentioned that we can put power series in function pattern. F, x, in this case, in short form, I will just write the blue color F there. Okay, it represents function. Okay, yeah. So this is what you see just now, before the break, right? We write function equal to C sub 0 means the first number. And again, power series, we always start with n equals 0 first, then until infinity. This is happen in power series. That's why the first number always a constant value, and so on. This one is familiar. We keep repeating this formula. And our x minus a must less than r to become convergent. This is one of the example that we see just now. So you want to get convergent, your denominator cannot be 0. If not, it becomes infinity. Okay. So now what we want to do is that we want to determine what is the coefficient inside the power series. What is the coefficient Cn in a power series, or C0, C1, C2, C4, and so on. But in general equation in power series, you see the Cn, right? Cn in terms of F. So how do we do that? Now, what happens if we look at the blue color equation? What happens if we put x equal to a? What happened to this equation? What happened to this whole equation or this whole series? What do you get? If this is the, you see blue color function, and you add all the number together. However, what happens if you put your x equal a? What do you get? Edmund, what do you get? this equation, the whole equation, you add number together, right? But now what happened if you put x equal a? What do you get? What do you get?
A minus A.
Yeah, x minus a. Now you replace x equal to a. What do you get?
C1.
Huh? X equal a. What do you get? You still get C1. X minus a. Now your x is a. So a minus a. What do you get?
0.
So C1 times 0. What do you get?
0.
Now the next one, Edmund. What do you get? Now your x equal to a. What is this equal to? What do you get, Edmund? When your x equal a, what do you get?
0.
How you get 0? X equal a minus a 0, 0 times C2, you get 0, and so on. But however, what about the first number? Do you have x in the first number there?
No.
So what do you get? If your x equal a in the power series, what is the final answer you get?
0.
0. What does C sub 0 means to you? What do you understand about C sub 0? Shakir, you want to try to explain what is C sub 0 means? Shakir? Shakir first time. Calling for Shakir. Second time. Those watching YouTube, you can fast forward. Yeah, Shakir, what is C0? What do you understand what is C0? In power series. What is C0?
1.
1 is a solid number, right?
Yeah.
Okay. Now, just continue the question I asked Edmund just now, Shakir. If you add this whole power series together, but now your equation, your x equal to a. What is the final answer if you add all the number together? Now your x equal to a. What is the final answer you get?
0, sir.
0. Okay. Do you understand power series? Actually, you add all the number together, right? You add C0 plus C1, x minus a plus C2, and so on, right?
Yeah.
Yeah. Hold on, yeah. Hello, I'm in class. I'll call you back later. Yeah, hi, I'm in class now. Yeah, hi. Okay. Now back to our equation here. Right, Shakir. Just now C1 you say is 1, right? Shakir, are you there?
C0.
C1, C sub 0 is 1, right? And then you plus, because you're adding, you are doing power series, you add all the number together. What is the second number?
0.
0. Plus third number?
0.
0 plus fourth number also 0. But you add all the number together, you still get what?
1.
1. You still have C1 in the equation if your x equal a. Correct?
Yes.
Does it make sense? If I say this whole number, this whole series, if I put my x equal a, I will still get C sub 0. I will still get 1 constant value. Correct?
Yes.
Does it make sense? Nizam, does it make sense? Nizam? Nizam? Okay. Okay, Edmund, do you understand what we are discussing just now?
Yes, sir.
So, okay, again, power series, Edmund, this question for you. What is the final answer if you add all the numbers using this equation? If you put x equal a, what do you get?
1.
Can you put 1 equal what? In the general equation, what do you get? If you use this equation, what is the first number you see in this equation?
C0.
If you add this power series together, you'll get C0. Okay, we'll get C0. But in the previous example that we have, we know that power series always start with 1. So we know that if we add all the power series together, we always get 1, or the first number, first constant number. So this is the equation that we have. So like what I explained just now, you can cancel the second terms onwards, because second term onwards you get 0, and you arrive at C0, C sub 0, if you replace x equal a in the equation. Okay, we'll talk about general equation now, right? So use general equation to explain. All right. And this is the convergent criteria. Your x compose x minus a must less than r. Okay. Now, when you differentiate the series by term, mean this one. If you have a function f, you differentiate mean you dy dx, means the whole thing here is y equal to y. You dy dx. You dy dx, what do you think you'll get? This is your f, right? If your x equal a, you will get C0, right? You know C0 is a solid number, is one number. So you dy dx equal what? Shakir, just now I asked you a question before we break. If you y equal 2, you dy dx, what do you get?
0, sir.
0. So if you C sub 0 is a constant number. So if you put this as an equation and you differentiate it one time, you get 0. So if you differentiate this equation with x equal a, with all these, if you differentiate, if you don't want to replace x equal to a, you also can do the normal differentiation pattern. So you differentiate the first one, c sub a 0. You know that c sub a, the first number is a constant value. So constant value, you differentiate x, you get 0. And you go to this one. You go to this one. So you differentiate this one, you get c1. You differentiate this whole set here will equal to 2c2 x minus a, and so on. You'll get this one, and dot, dot, dot. You substitute a inside here. Substitute a inside this equation. So this one 0, 0, you will still get C1. Okay. So you differentiate one time, you get C1. The function before you differentiate, if you have x equal a, you get C0. You differentiate one time, you get C1. Do you want to guess if you continue to differentiate second time? If you differentiate this equation second time and then you replace x equal a, do you think you can guess what is the double differentiation you will get? I'll do it one more time for you. Differentiate one more time. This one, ignore the red arrow. This one, you differentiate one more time. C1 is the constant number. You differentiate is like y equal to 2, dy dx equals 0. So this one equals 0 because this is a solid number. And you go here. You dy dx, you get 2c2, and then this one, you get 1, right? So you get 2c2. You continue with this one. You differentiate. When you differentiate, the exponential pull to the front. 2 times 3, you get 6. 2 times 3, you get 6. C3, and you copy this one. You get x minus a, and so on. You do the fourth number also same. You get this one. And then you replace x equal a inside this equation. This one you get 0. This one you get 0. You get 2C2. Okay? You get 2C2. You differentiate one time, you get C1. You double differentiate, you get 2C2. Let's do one more time, whether you can see the pattern. Repeat one more time. If you differentiate this equation, this whole equation, one more time, this one is going to be 0 because this is a solid number or individual number. You differentiate dy dx, you still get 0. This one you get 6, or 2 times 3, you get 6. C3, and then this one is 1. You get C2, and then this one, and so on. And then you replace x equal a in the equation. You can cancel like this step and this step. You'll get 2 times 3 C sub 3. Okay, you get, or you can write in this form, 3, and then symbol, this one. Go and recall what you learned in Max 1. You can write 1 times 2 times 3. You can write in this form. This is the sum. This is the products of 3 number together. If you write 3, this symbol, it means you take 1 times 2 times 3. You get this one. If you see 2, this symbol means 1 times 2. If you see 4, means 1 times 2 times 3 times 4. Okay, recall. We recall the notation of this one. Look at the pattern. The function is this one, but you replace x equal to a, you cancel this one. You only get C0. You differentiate 1 time, you get C1. Differentiate 2 times, you get 2C2. Differentiate 3 times, you get 2 times 3, or 3, this symbol, C3. Can you write the pattern that you see over here in the f power n, or f, the number of differentiation to the answer? Can you try to guess the form of equation from the second line, third line, and fourth line into a general equation? Can you try to think, maybe 10 seconds to think about how do you convert this pattern, this pattern, this pattern in the general equation? Use the sub n or superscript n to represent this set of observation. Oh, sorry. So again, do you see any pattern over here? So you can actually write this pattern in this form. All right. So you can write this differentiation pattern in this general equation. You can write f power n, n means numbers of differentiation, times 2 times 3 times 4, and then continue to times depending on the n that you have. And C sub n, n depends on the number of differentiation. For example, you take number 2. Number 1, maybe you cannot see it, but you can see beside the C1 is actually 1. And the first line is actually f differentiation 1 time. So f n equal 1. And then beside Cn, actually there's a 1 there. So this n equal to 1. And C sub n, n for the first one is 1. And number 2, what is the far left that you see the f power n? Is when you double 2 times, your n become 2. So according to this equation, this is 2 c sub 2, and number 3 actually is 3 this symbol, and cn. Okay, so this is how you write the differentiation in Taylor series or Mccarran series. So theorem 6 give you the pattern of differentiation. You can write in this form. You can write equal to n, this symbol, and c sub n. This slide is important for your coming test and final exam. So you can convert the function to this one if you want to do differentiation. This is a function that you have, but when you do differentiation, you have n, this symbol, and c sub n. Again, n proclamation mark equal to the number that you times together. Okay. So this is how you try to determine the coefficient of Cn in terms of function. Okay. So you can see the far left, the blue, f superscript n a, because you substitute your x equal to a inside here. So you can see we replace the x as a in the equation, equal to c equal to n explanation mark cn. So you rearrange this equation into this equation. I don't need to explain, right? Here to here, you just move your n progression mark to the left, means divide. This one is multiply. When you move from the left to right or right to left, multiply become division. This is the equation that we're looking for when we want to find Cn in terms of function. This remain valid even your n equals 0, even the first number is valid. Okay, you can test it up. What happens if you replace your n equals 0? So f power 0x will equal to 1. Okay, so you use this equation. What happens if you replace your n 0? So f power n is 0, x equal to, your n is 0, so 0, this symbol. C, your n is 0. So 0 progression mark is actually equal to 1. Again, remember this one. This is a very important mathematics symbol for this module. And you won't tell you this, we won't mention it in a question, but we expect you to know 0 progression mark equal to 1. Okay, 0, this symbol equal to 1. And you learn this one, you should learn this one in mathematics 1, engineering maths 1 before this. Okay, yeah. But if you didn't know it, you learn it, then I mentioned this one in module. So once I teach you this one in our module, we expect you to know. So there's no more reason that you don't know. 0 progression mark equal to 1. Remember, we're going to repeat this one many times. 0 progression mark equal 1. Theorem 7, the new truth for today. If function had a power series at a, means you substitute your x general equation, x equal a, you can use this formula. Your general equation, fx equal to power series, Cn is your constant value, x minus a power n. If you want to calculate, put in a function, you use this formula with your x minus a less than r to become convergent. Okay, so this is a reference formula for you to solve question. Theorem 7. I highlight in a red color, means it's important. And we already proved to you how to arrive at this one just now. Cn equal to f power n a, because we replace, to get this form, we replace x equal to a in our calculation, where we can cancel all the term behind. So a is here divided by n progression mark. Yeah. Again, I highlight this one, is very important for your test 1 and final exam. Okay, repeat the video if you don't understand the blue color, what does it mean, how do you arrive at this one. Okay, repeat this video, watch it again and again. So I put it in another slide again. This is a very important theorem. Huh? So what happens if we substitute this Cn, that we proved just now, Cn equal to f power n. Again, this n here, f power n here, is number of differentiation. It's not exponential. Again, just now, what we proved to you, f n, this n here, f function n here, this small n here, is number of differentiation. You differentiate how many times? It's not a power. It's not a normal exponential power, meaning take note on that. This is how many times you differentiate the thing. So you substitute this equation, this one, inside here. So from here, you substitute, you use this one, substitute inside there, you get the equation, the new equation, this one. But using this one, I highlight in the box, you use this one, you're able to do any question, because you just substitute value inside here, then you substitute there, you're able to find the answer. And you expand this equation. Actually, this equation, this power series here, how you get the first number, how you get f bracket a, you substitute n equal what? According to this equation, Nizam, according to this equation that you see here, the first number, what is your n?
First number 0.
First, correct. Because you see the sum number that you have here, and we are talking about power series now. We're still in the power series, but anyway, you just look at the symbol that you have. You see the lower limit n equals 0 there. Actually give you hints already. This is a power series. So n equals 0, you replace n0 here, x minus a 0, you get 1, right? Anything power 0, you always get 1. Again, Nizam, question for you. N now is 0. 0 progression mark equal to what? This one. 0 progression mark equal to 1. So f0 a divided by 1 times 1. You get f power 0, not power, but the normal function 1. You get the first one. Then how you get the second one? You replace, now the first one is 0, n 0. Second one, again, power series, second one is 1. 0, 1. So n equal 1 for the second number in the series. So you replace n1, you get this one. So you get this one. Then n become 1, you write in this way, and you differentiate one time. Differentiate one time, you use 1 comma, f comma a. Okay, f comma a, and then 1 progression mark. Continue. If you want to find the third number, because third number you start with 0, 0, 1, 2. The third number is 2, n equal 2. So n2, 2, progression mark, f, 2, and then a, and so on. Okay, so this is how you apply this red box here. And just to introduce you, if you haven't heard Taylor series before, this one is called Taylor series. The name, when you expand this red box, if you use this red box, this Theorem 7, you expand it into this one. You expand in the function form, fa plus this one plus this one. We call it Taylor series. So Taylor series is very popular when you want to do your degree later. Okay, Taylor series is, you use Taylor series in final year, degree final year module. For example, fluid mechanics, finite element analysis, and so on. So this is important. Okay, this is important. So for a diploma level, we just introduce you this pattern. So at least you've seen this pattern before. At least you look at this pattern, you know this is called Taylor series. Taylor series, again, start with function. Taylor series is deal with function and deal with differentiation. How many times differentiate? Okay, so first one Taylor series start with function, and a function is not a number anymore. It can be number, but a more appropriate address is in terms of function, or y equal to what? Equation already. Taylor series deal with equation, and also deal with differentiation 1 time, 2 time, 3 time, and so on. This is called Taylor series. Again, this pattern is called Taylor series. And the function f, the function that we use in Taylor series here, is around the value of a. Okay, around the value of a. So what happened when a equals 0? We have a special case here. So we need to mention what happened to this Taylor series equation. This Taylor series equation. What happened if your a equals 0? What happened if your a equals 0? You substitute your function, your Taylor series will become, or use this equation. Okay, use this equation, you substitute a equals 0, you get x. You continue to copy n over here. Fn 0 and n copy. And you expand this equation. You expand this equation in this pattern. So the first one, you will get f bracket 0. Second one, differentiate 1 time, 0, 1, progression mark, x1, plus differentiation, double differentiation, 2 times, 0 divided by 2, progression mark, x power 2, and so on. On above, this is Taylor series. When your a equals 0, another name was given to this set of data called Mccarran series. Taylor series, this pattern. If general, or how you memorize it, you memorize the box, this one. You memorize Theorem 7. You expand this equation here in the equation form, in this series form, you get Taylor series. And if you replace a equals 0, in the Taylor series, you get Mccarran series. Okay, you replace the A in the Taylor series at equal to 0, you will get Mccarran series. Do you see the relationship? Actually, Maclaurin come from Taylor series. Or you can say Maclaurin is also one type of the Taylor series. Why? By replacing A equals 0 in the Taylor series, then you get Maclaurin. This is how you differentiate this one and this one. Taylor series. And just a quick question, maybe just a quick question. How does Taylor series become Maclaurin series? Are you able to answer that question? How you change Taylor series into Maclaurin? Nizam, you want to try to answer? How you change Taylor series into Mccarran series?
Change A equal to 0.
Okay, so the answer is quite simple, but sometimes we forget. So sometimes the answer is very simple. So again, so by these slides, it's very straightforward. By replacing the Taylor's inside Taylor series, you're replacing Taylor series x minus A, you replace A is 0, you will get Mccarran series. Another important box here. Okay, let's look at the time. Let's go for one example, then we call it a day. Now, proof. This question asks you to prove Theorem 7. Theorem 7 means this box, or Taylor series box. This box, okay. That function, this function of y equal to this equation, fx equal to 1 over x. Again, when you see x, it means power series. Has a power series representation given by this one. So 1 over x equal to sum of the number. And again, you see what is the lower limit? N equal 0. You start from 0 until infinity. Again, it meets the criteria. We call it power series. You always start with n equals 0. And you're given the general equation. X power n equal 1 plus x squared and so on. X must less than 1 to be convergent. So it gives you one statement here. You need to prove by using Theorem 7. So recall, right, for example, in the test or final exam, ask you to prove. When you see the word prove or explain, or not explain, but to solve or to solve question, most of the time, what we expect you to do is you call the correct theorem out, or you call the correct law out, or you call the correct equation out. So in this case, it gives you a direction. Of course, in test or final exam, we will not this direct. Okay. Or it can be just by using theorem or by using a suitable theorem. Prove that the function equal to this one, for example, this kind of question. So we already explained the red color theorem just now. We want to apply the red color equation in here. So you write the equation from the question. The function equal to 1 over x. Then you start counting. You replace your x equals 0. And then put into the equation 1 over 1 minus 0, because your x now is 0. So your 1 over 1 minus x, your x now is 0. So you replace with 0, you get 1. What happens if you do differentiation? When you do differentiation one time, you get 1 over 1 minus x squared. You replace with 0 also. You differentiate one time, replace with x in the equation. You'll get 1, because 1 divided by 1 minus x, x now is 0. So 1 power 2, you still get 1. 1 divided by 1, you still get 1. You differentiate 2 times. You differentiate 2 times. You're going to get 1 times 2 divided by 1 minus x. power 3. So I'm not going to explain how you differentiate this one because you learned in Maths 1 already. Okay, how to do the differentiation, I'm not going to explain in this module. We assume you already know already. Okay, if you don't know, flip back to the advanced mathematics textbook. Go and learn how to do differentiation. Okay, then you replace double differentiation, x equals 0. So you'll get 1 times 2. Below there is 1. And then you power 3, you still get 1. You get 1.2. You continue to do the fourth one. Not fourth lah. Number 3. Differentiation third time. You'll get 1 times 2 times 3 divided by 1 minus x power 4. You substitute 0 in the equation. You'll get 1 times 2 times 3. Do you see the pattern over here? After you derive equation, you look at the pattern that you get. Then you write in the equation. So I pulled all the equation that we done just now. And then you try to write a pattern for this one, and this one. You can write this pattern 1, 2, 3 in the red color pattern. Okay, this one you need to spend some time to digest how to put this one into here. Okay, on the left hand side pattern, you observe from the first line until the last line. What happens if you increase the differentiation on the far left? On the far left, we have 2 columns here. View the left one. Okay, first time, differentiate first time, 2 times, 3 times, you get this equation. Okay, what about this side? Over this side is more simpler. It will follow how many times you differentiate. Meaning you can straight away use n progression mark. Okay, because if you differentiate 1 time, you get 1. Differentiate 2 times, you get 1 times 2. 1 times 2, what does it mean? It means 2 progression mark. What does 1.2, 1 times 2 times 3, what does it mean? You can write in 3 progression mark. You compare side by side. You can use this one to solve this kind of question. So you replace your x equals 0. You replace x equals 0 in the top equation here. You will get n progression mark because below denomination you get 1 no matter how big is your n, and you can arrive in this equation. Okay, so you arrive at Cn equal Fn 0 divided by n progression mark. And this one, okay, how do you get this equation? How do you get this equation? By theorem just now. By theorem just now. Theorem 7, we already proved Cn equal to Fn A divided by n progression mark. Now your A is 0. You just substitute this one as 0, A is 0. And substitute what is your Fn over here. If you do the calculation, below there, 1 minus 0 is you get 1. 1 power n plus 1, you still get 1. So you arrive at n approximation. You continue to do n approximation, you carry forward this one. This one divided by this one, you get 1. So your Cn equal to 1. Once you get your Cn equal to 1, remember the Mccarran series just now? Mccarran series you derive from a Taylor series where your A equals 0. So you pull out the Maclaurin equation just now. Fn 0 divided by n progression mark x power n. And you start, this is what we show you just now in the Mccarran series. So relate Mccarran series to the one that we have. So 1 over 1 minus x, the blue color, the question, equal to fx. And we can use Mccarran series. This is a Mccarran series. We just tap into here. You can write in this form. Why you can get 1 in here? Because just now we do the calculation. F differentiation how many times? N 0 divided by n approximation. You get 1 here. You replace 1 in this form. That's why you get 1 here. This one you carry forward. And we prove that this series can be written in power series of x power n. This is how we prove this one equal to this one. Okay, so this is a proving steps. Okay, so maybe you look at question 24 in our next class. We stop our lecture here. Let me stop the recording.